Hello, developers of ROS. Today we are going to see here how to create a custom service message and how to use it inside the service server. So for this we are going to use the ROS Development Studio. As always, remember that you can access the ROS Development Studio for having a complete ROS environment already installed for any computer, Windows, Mac, or Linux, by visiting this address rds.theconstructsim.com, and you will get a free account and you can do whatever you can see in this video. So it's also for all the free users. So let's go for that, creating a service message, a custom service message. Then first we go to our projects private area, and then we create a new project. Let's call it, so for example, custom service message project, and this is for the YouTube audience, for example. So let's create it. Okay, created. Here we have it, and now let's open. We open it and we get here the development environment. Then first thing we need to do is to create a package that will contain the message. And which kind of message we are going to create? Okay, we can do whatever. This is just an example. Okay, so the first thing is, let's make for example, my suggestion for this video is let's use the BB-8 simulation, the robot of Star Wars. Let's use this simulation, and then let's create a service that when it's called, then the BB-8 will return the amount of distance that it has moved since the very beginning when the robot was switched on. Okay, so that's the service that we are going to provide in order to any other programs maybe that need this information. This is just an example. Okay, so for that let's start the BB-8 simulation. You can see here in simulations you go to BB-8 and you can launch it. So we'll get the simulation here in a few seconds. Here's the starting. So we have the BB-8 there. Now another thing, let's go on. In the meantime, let's go and create the packages. So if you go to tools and open the IDE, you will see the different workspaces that we have here in the ROS Development Studio. The AI for specific training on TensorFlow or OpenAI, Catkin workspace, that it's about the place where to put our ROS code. This is where we are going to work today. Then the notebook workspace, where notebooks with instructions and documentations can be, or the simulations workspace, where specific custom simulations can be placed. So we are not going to use anything of this, only the Catkin workspace here today. So we go to this and create a new package. How do we do that? Well, let's open a shell and go to that directory, to the Catkin workspace source. So we go cd Catkin workspace source, and here we create our first package. It's going to be the package that defines the message. So Catkin create package, let's call it distance service message, for example, and that's it. So yeah, there it is. It has appeared. Oh, sorry. Yep, here it has appeared here, the new package. And here inside this package directory, let's create another folder that will be the service SRV folder that will contain the package, the message, the definition. So here is where we are going to put our message definition. For this, we come here to the service and then add a new file that we are going to call it, for example, dist message, or my dist, yeah, my dist dot srv. So it's our distance custom messages. Okay, so let's open this here. Let's make it bigger. And also the the font. So what do we have to put here? Well, we have to put the definition of the message of a service. And as you know, the service message has two parts. The first one is the request, the one that contains some information for the server about what we are requesting the service to do for us. And then the second is the response, is what the server is returning to us. So on the first, we want to know the distance that this BB-8 robot has achieved up to now, has moved. And then let's make, in order to make it more interesting, so let's assume that when we request the service, we want to know the distance in a certain units. So maybe we request the units in miles, or maybe we request the units to be in meters. So we would like to know the distance moved by the robot in different units, miles or meters. Okay, so then first on the message, let's create the definition of the first parameter that this message will have, that is the units. And this will be a string, for example, that is called units. So we have a message that provides requests to the service and provides the units in which we want the result. And then we divide the answer, and the answer will be a float containing the distance. Okay, so that's just the definition of the message. We can save it, and we have it here. Now, in order to have this working, in order to have the message compile, we need to compile it, and for this we have to modify the CMake list first and the package XML. So let's go first for the CMake list. Then the first thing that we have to do is to go to the find package, that is here, find package catkin required, and then include here the components. So we have to include required components. Make sure that you have this, okay? Find catkin required components, and then which components do we need? So we need the std messages. Oh, sorry, not in capital. std messages, and then also the message generation. Okay, great. That's the first change. Then we have to go and add the service files. So this is here, add service files. So this we have to uncomment in case that you don't have it commented. Also the files, and then here we need to specify our service file that we want to compile. That is this one that we have defined it here, my dist. So my dist service. Okay, this is just another example. Service 2 is just an example, and then we remove the comment here also to close this. Okay, great. Now we go to generate messages. So we have indicated, hey, please add the service files, and now we have to say, yeah, so generate the messages for services. And we have to comment this, dependencies, and standard messages also in this case. And in case that you need some other packages requiring definitions of messages here that you have used here, then you will have to add them here. Great. Then final step is to go to the catkin package here, and then indicate that is catkin depends, it's required, this option is required, and catkin depends on ROS Pi. Okay, so we have everything on the CMake, and we can save. So save, and now let's go and modify the package XML of this message in order to allow the compilation. So let's see here. We have to go here to the build tool depend, and in here we have to add two things. We have to add a build depend and a run depend. So we have to add the build depend is here. Yes, so let me copy and add it here. And which will depend the message generation. And then we need the run depend message runtime that is included here. This is by default provided when we create the Catkin package. So you can copy paste based on this. Great, we have it. So now we have everything and we are ready to compile. So we can see if this package compiles, and we have provided everything. So let's go and then go here. We go one directory down and we do the Catkin make. And we see if this is working or not. So it is compiling. Let's see if the packages are compiled. So the message defining the service is compiled and generated. So once this is compiled, we can use it in our server service that we are going to use for receiving calls. Okay, we have a problem here. It says Catkin package depends on the package ROS package, which is okay, yes, and this is because we haven't specified here that ROS package is needed. So, and this let's see, let's copy this and then add the ROS package here. Actually, this is not required for these messages, but anyway, just as a standard way of doing it. So let's do it again. Let's recompile and let's see if everything is correct now. Let me see if there was another error for whatever reason. Okay, yeah, no. So in theory, this is the only thing that we need to do. And let's see. So what I was saying is that once this is compiled, this message here will be available as a Python definition and then we can use it in our programs, in the server, in the service server that we are going to create. Okay, so yeah, so compile, fine, good, very good. So now let's go again to the source and create the service server that we want to use this message, so that it receives those messages and then generates the response. So for that, let's create another package that is called Catkin create package. Let's call it distance move, for example. That's the package that depends on ROS package. That's the package that will have the service, and whenever somebody calls that service, this package will return the amount of distance that the robot has moved. Okay, so we have it. So this, we don't need this anymore. And here we have the distance moved. Inside the source, we are going to put a new file that is going to call the node. Just a node. It's a Python node that is going to contain the service, the server. So let's start by adding the command that specifies that this it's Python code. Okay, we got it. And yeah, and then let's import ROS package. And now what are we going to do is, what we are going to do is to create a class to store the service. So so this will be more easier to manage the callbacks and the different global variables that we need. So they will be not global but included into the class. So let's create that class that is the one that is going to provide the amount of the service and the amount of distance. So let's call it distance calculator, and this has a definition this in here. So what we are going to do is we need to connect to the odometry of the robot. in order to get the odometry so we can calculate the amount of space that has moved. For that, let's create a subscriber that has to belong to the class. Let's call it odom, and it's a ROS subscriber that it's connecting to the odom. What is the name of the topic for this robot? We have to check. So if we do a ROS topic list, we can get the name of the odometry topic that is called odom. Yeah. So in other robots, this could be different, of course. It depends on how it has been done, the robot simulation. So we have this, then the type of message is the odometry message. And then let's define a callback that it's going to be activated every time that a new odometry message is received. So this is the, for example, compute distance. Okay, so that's it. Then we need to include this message here that we have include. So we need to import it, and then import. Instead of doing like this, let's do only from. Odometry belongs to navigation messages package .msg import odometry. Great, we have it. So we need to define also in this class the initial distance and the total distance, and set that to 0. So let's call it total distance equals 0. Done, 0.0. And then let's also memorize the last position that the robotic was. So we can use the last position against the new position and calculate how much has moved. For that, let's also compute another variable called last position equals point. Is of type point. Why? Because if we do a ROS message show of the odometry, you will see that the odometry has a lot of information, but the only one that we are interested now is in this pose position that is of type point. Okay, so that is where we are going to store this information, only those 3 variables from the whole odometry message. Then now we have to import this point message because it doesn't exist. So we do the same as for the odometry. From, in this case, is geometry messages.msg import point. So there it is. We got it imported. Great. And then finally, let's create our service and let's provide this to the wall. So let's define, let's call it self like SRV, and for that ROSPy.service, and let's call it, for example, get distance. That is of type. Which type is this one? So is the type of message that we created here, that is my dist, as I mentioned, is the same name as the name of the file. So here we have to put my dist is this time, and then this is the type, and then the callback that will be called every time that somebody calls this service. So which one function will have to be activated? So let's call it service callback, for example. Very simple. Great. Now we have to import this message because we don't have it in the same way as we didn't have that one. So we do the same thing. And then from where? From this service message package that we just created. So let's specify here this service message .srv. So it's this with the name of the subdirectory where the service has been defined. Then import my dist. Okay, we got it so far, so good. Now let's go for the different callbacks. So here we have Now we need to get the callback for the odometry. So let's create this function here. So definition of compute distance, and then get a self, and also it receives the data of the odometry, of course. And here what are we going to do is to set this from the data, just get the position, okay? And let's call it, for example, P is the current point, current position. And as I mentioned here, we only want from the odometry, we only want the pose position data. So from the whole data of the odometry message, we are going to take only the pose position data. So now in P we have the latest point that contains only this. Sorry, only this. Okay, it's a point. Great. Now what we can do is to compute the distance between the current point and the last point. So where was the last point? The last position here. In this case was 0. So what I suggest is that we set this to the initial position of the initial odometry message. So the first time that we receive an odometry message, we don't know when this service has been started. Maybe the robot was already moving. So we need to set the last pulse to the first odometry message that we receive. So for that, let's do something. Let's assign the last position to the first message. How do we do this? Only for the first message. For that, we need to do a kind of checker, a check. So that let's call, for example, first odom that equals true. And then here, if we are in first odom, if self first odom, then first we set the self first odom to false, so we don't repeat this anymore. And then we set the self last position to that P that we have just received. Okay, so this is in order to get the first last position correct value, not the default empty value. So now we are set for the first one that we receive this. This is important because otherwise we can get many errors in the distance calculated, depending on how much the robot was moving. So now we are in the position to calculate the distance. That is just a root square of the differences between the 2 points, and I have it already created here. So just to go a little bit faster because it's a little bit tedious to write it down. So basically it's the difference between the current point and the last point. So current point minus last point in the X, multiplied by itself, and then on the Y, and then do the square root. For this we need to import here math. Okay, so we have here the distance calculated. Great. So now that we have this, we can add this distance to the total distance. That is self total distance plus the current distance. And also finally we have to set the last position to the current one. So self last position equals P. And that's all for the odometry. So the odometry only does that. And then at any point in time, this is running. So at any point in time, we have in this variable, we have the total distance. Now let's create now the callback for the service. Definition of the service that was called service callback. Okay, so service callback self, and then the request that we are receiving in this service. And for this, what we want to check first if it is in miles, what the person, the program calling this service wants the distance in miles, or in kilometers, in meters, sorry, in meters. So let's first grab, just to simplify, okay, so this is just to simplify, let's grab the current distance. So self total distance. So in this, now we have the total distance at this point. Now let's check if the request is of request dot units equals miles. Then why is that? Because request is the whole message of the service that we have defined here. So request contains all the parts here, and then we have it contains this part here, okay, and inside this part we have a field that is called units. If we had any more parts, any other types, for example bool, status, for example, we will also add them here, and we will be able to access to them here in the request in the same way. But this is not the case, okay? So let me just delete. So if the request dot unit contains miles, then let's modify the distance by a certain amount that is about 0.00062, for example, more or less. Not need to be super precise. Okay, so if the request is in miles, then we'll change from meters to miles. So now in this there are miles. Why? Because the odometry is always measured in meters. So by default it's already in meters. So we have here in distance, the distance depending on which units we have specified. And now we just have to provide this as a response. Then for that, let's create a response. Which type is the response? Then the response is the same name as we have here in the file name. So it means my dist. And then we have to append response. It's a new type that is created automatically when we compile this directory. So now what this means that this message, we don't have it. We haven't imported yet, so I'm going to import here from the same package as my dist. So here it is. Great, so we have the response, and now we have to fill it. The response message on the field called dist. Let's put our distance, the one that we have calculated here. So dist is because here we specified dist. So we have generated a Python message with this format. Okay, that is this. And then finally, we just have to return the response. That's it for the callback of the service. So every time that somebody calls this service, this function will be activated and this information will be sent. We are about to finish, so this is for that class. So we are done with the class. So now let's do an initialization of the node. Init node, and let's call it, for example, let's call it distant move. And finally, let's create an instance of the class. Calculator, we got it, and then we just wait there forever. So we do a ROS spin and we stay there forever. So this service will be running all the time. Okay, so we got it. That's all. Now let's try to use it and see how it works. Very, very simple. So first thing is that we have to launch this node. So for that, ROS run. Oh, wait a second. We have compiled here the messages, but this shell, because it was already running, has not sourced the messages created during the compilation. So because of that, we have to do a source of the devel setup.bash. Yes. Now we can run our new package that is called distance move. Distance moved node.py. Okay, and so yeah, so we don't know if it's running or not, so we better do something like put in some message here that indicates when this has been initialized. So let's put a ROS.py log info indicating that everything is running. So service is running. Okay, so we got some feedback about what is happening. So let me launch it again. So yeah, service is running. Okay, great. So this service is running. Now what we can do is to open a new shell and then check that the actual service is there. So if we do a ROS service list, should have here the get distance. Here it is. So we got our service there, and if we call it ROS service call get distance, then with the type units we specify meters, distance 0. Why? Of course, because we haven't moved the robot. Miles 0. Okay, correct. So everything looks like it's working. So now let's move the robot. For that, open a new shell. Let me put it here and launch a program that is already there that allows us to move the robot using the keyboard. So it's ROS launch BB-8 teleop keyboard teleop. Okay, so now we can move the robot. So if I move the robot a little bit, yeah, remember that each square is 1 meter times 1 meter. So now if I call again the service in miles, it will tell me a certain amount. Yes, I suppose that is correct. And yes, it's around there. So it's more or less 1 meter. It's about 1 meter. Okay, so that's it. Basically, you got it. So you understood how to create a package with a service message, custom service message, and then how to use it inside your own program, your own service. So that is all. Thank you very much for attending this video. Remember that if you like these videos, you should subscribe to our channel because we are publishing one new video every day, answering these questions or posting about very interesting projects with ROS. So please subscribe, and just remember that we have released a ROS Developers Conference. That this is an online conference that we will do in July, and this conference, everyone will be, all the participants. It's an online conference, so you don't have to travel to somewhere. You can do it from home, connecting to an online platform where you will be able to do at the same time as the speakers are speaking. You will be able to do the exercises and the same things as the speaker is explaining there. So if you are interested, just visit our website at rosdevcon.com. So you will find the link beneath the video. So thank you very much, and see you on the next video.